Now next topic, that is relation between field and potential. Say here, suppose we consider two equipotential surfaces close to each other having potentials V and V plus delta V. So here delta V, that is the potential difference, or we can say change in V in the direction of electric field. Here delta L, that is the perpendicular distance between these two equipotential surfaces. Now imagine a point P on surface B. Now suppose the unit positive charge is moved from point P to surface A against the field. Clear? So in this particular case, the work done, that is E into delta L. Here delta L, that is the distance between these two surfaces. So we can write this work done, that is the potential difference between these two surfaces. So as per that, E delta L, that is the potential difference between these two, that is when it is moved from B to A, so potential difference is VA minus VB. Potential on A, that is V, on B, that is V plus delta V. So we can write V minus V plus delta V. So it will be minus delta V. So here we can write E, that is equal to minus delta V by delta L. If you take only magnitude wise the relationship, then you can write E, that is minus delta V by delta L, that is delta V upon delta L simply. If electric field, that is uniform one, then simply you can write here the relationship, that is E, that is equal to V by D. Okay, and here this relationship that we can use to solve many problems and MCQs, right? Now here we take this particular relationship. Now we can write the relationship like this also. E equal to dV by dr, and in vector form you can take E vector, that is dV by dr. Now in this particular case you have to take partial differentiation, because R, that is the function of x, y, z. Okay. Now that we will discuss what is the partial differentiation and how it is carried out. So here we can write this particular equation as E, that is equal to, now if we take the vector form, then we have to consider the negative sign also. So minus del V by del x I caret plus del V by del y j cap plus del V by del z k cap. Okay, and this is the partial derivative. Clear? Now later on we will discuss how this one is carried out. But here very important thing that you can observe, that is with the help of a scalar quantity, the potential, you can find the vector quantity. You can find the vector quantity. Now from this particular relationship you can conclude for these 2 points. Say here, one, that is electric field is always in the direction in which the potential decrease is steepest one, means maximum decrease in the potential takes place always in the direction of electric field. And second, that is, suppose here we consider this particular displacement, that is unit, then if the magnitude, its magnitude means the magnitude of the electric field that is given by the change in magnitude of potential per unit displacement normal to the equipotential surface. So perpendicular to this equipotential surface, if we take the unit displacement, then per that unit displacement, whatever is the potential difference, that will give you the magnitude of electric field. Clear to all of you? Now see, in the previous theory we discussed this thing, the relationship between electric field and electric potential. If the electric field that is uniform one, then simply we can write E that is equal to V by D or V by R simply. Okay? But in the electric field, if at different positions the potential is continuously changing one. Okay? And it depends on suppose X, Y, Z, and the field that is also changing in that particular manner. Then how we can find the electric field at a particular point? So in that particular case, we have to consider the partial derivative. So now let's take one simple example related to it. This example is not given to you in the text, but for understanding we are taking this one. See, in a certain region, the electric potential that is given by the formula V, that is a function of xyz, 2x square y plus 3y cube z minus 4z4x. Find the components of electric field and the vector electric field at point 1, 1, 1 in this particular field. Okay. So, see here. Now, V that is function of xyz and that is given to you, and the point where you want to find the field, that is 1, 1, 1. Now we have to take first components. So if you differentiate this V with respect to x, then it will give you x component of electric field. When you differentiate V with respect to y, it will give you y component of electric field. And when you differentiate V with respect to Z, then it will give you Z component of electric field. Now let's see. Ex, that is del V by del x. So we can write that is del by del x of V. Substitute the value of V here. Now differentiate it. So for x square, the differentiation is 2x. So first term, that is 4xy. In second term there is no x, so it is constant term. So differentiation with respect to x will be 0. Here differentiation of x is 1, so that is minus 4z4. Then after, substitute the value of x here, because we want this particular component at this point. So here x is 1, so substitute the value of x is 1, y is 1 and z is 1. Okay, so you will get 0. Then after Ey, that is equal to minus del V by del y. Differentiate with respect to y. So now substitute value of V, differentiation of this first term, here differentiation of y, that is 1. So first term 2x square, differentiation of this one y cube, that is 3y square. So 3 into 3, 9, 9y square z. Here there is no y, means this will be treated as constant term. So its differentiation is 0. Now substitute here value of x, y, z. This coordinates 1, 1, 1. So you will get 2 into 1 square plus 9 into 1 square, 1 equal to 11. Then Ez equal to minus del V by del Z. So that is equal to del by del Z of V. Differentiate this one. So here in first term there is no Z, so it will be treated as constant term. Differentiation will be 0. For Z it is 1. So differentiation is 3y cube. Then minus differentiation of z raised to 4, that is 4z cube. 4 into 4, 16. So minus 16 z cube x. Now substitute x, y, z, that is 1, 1, 1. So you will get minus 13. Now E, that is 11 j minus 13 k caret, right? But here we have the relationship E, that is minus del v by del j. So resultantly you can write this is equal to minus 11 j plus 13 k caret. Or see, directly you can apply negative sign here also. If you take Ex equal to minus del v by del x, then no need to write here in this manner. But first here we calculated as per magnitude only. So now finally we have to represent as per the relationship E equal to minus del v by del x I caret plus del v by del y j caret plus del v by del z k caret as per that. Now apply one negative sign here, so your final result will be like this. So here see, with the help of scalar quantity, you will obtain the vector quantity. Clear to all of you?